concepts of reconfigurable walls and continuum surfaces emerging recently in the field of robotics, a wide range of applications, each having its own mechanism for manipulating the surface, have been proposed. Here we present one such idea of having moving walls in a conference. This continuum surface wall dynamically reconfigures its shape in such a way that it provides more room space for a session that is more populated, and simultaneously reducing the room space for a session that has fewer occupants. The idea here is to manage the floor area effectively in such a way that more space is provided where it is required at the expense of reducing the space at some other location. The active wall continuously senses the occupancy in different sessions and modifies the room capacity by adjusting its shape. There are temperature sensors installed in each of the session rooms which measure the heat intensity of the room. The walls are manipulated by a pair of tendons attached in each room, one near the ceiling and one near the floor at a point where it makes an angle of 45 degrees roughly with the walls. The tendons are driven by continuous rotation servo motors. An Arduino AT-MEGA328 microcontroller monitors the temperature sensors to detect an increase or a decrease in temperature in any of the rooms. Based upon this information, the microcontroller is programmed to actuate appropriate pair of continuous servo motors which correspond to the rooms that has to be increased and decreased in space. The level of actuation is proportional to the changes in temperatures. An internal cable connecting the wall at a series of points helps in distributing the pulling forces applied at one point throughout the continuum surface. This also maintains a constant volume in the space enclosed by the wall and gives an amoeboid shape to it as it moves. This idea of having a moving wall with intelligence embedded into it can also be used in many other living environments to manage room space effectively based on occupancy.